morning, everyone! I know that you can't imagine how we are to virtually conduct our sessions in mathematics, given that teaching and learning mathematics, as we are used to, is done face-to-face. But rest assured that everything will be discussed comprehensively. Just keep relaxed and hang on till the last presentation. I am Teacher Jane, your mentor for today's Grade 7 Mathematics. Today, we are to focus on the introduction to sets, after which you are expected to describe well-defined sets, subsets, universal sets, null set, and the cardinality of the sets. Let us start with our preliminary activity. You can open your module on page 12. Look at the given objects. If you are to group these objects, what are the groups? How many groups can be formed? You might say the group of round objects. Yes, these are clock, ball, and marble. Next is the set of sun protection. These are cup and umbrella. We have also the set of orange objects. These are 9, the orange rose, ball, marble, and party hat. Another is the set of counting numbers. These are the numbers 9 and 8. Does each object belong to a group? Is there an object that belongs to one group? Which one? You might consider the diamond-like object that does not belong to any of the sets we just mentioned. If that's the case, then you are right. This object is not a member of those given sets. Hence, a set is a well-defined group of objects that share a common characteristic. Let me introduce to you the three methods of writing a set. These are the statement or descriptive form, roster or listing method, and the set builder notation. Let us differentiate the three methods by observing how they are written. In the statement or descriptive form, a well-defined description of the elements of the set is given and enclosed in curly brackets. In the roster or listing method, elements of the set are listed within the pair of braces and are separated by commas. In the set builder notation, a rule or the formula or the statement is written within the pair of braces so that the set is well defined. In the set builder form, all the elements of the set must possess a single property to become the member of that set. In this form of representation of a set, the element of the set is described by using a symbol X or any other variable followed by a colon. The symbol colon or a vertical bar is used to denote such that, and then we write the property possessed by the elements of the set and then close the whole description in braces. The colon stands for such that, and braces stand for set of all. This time, let us consider this example, the set of counting numbers from 1 to 10. Let us write the given set in statement form. It would be set A is equal to the counting numbers from 1 to 10. In the roster method, set B has the elements 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. As you can see, all elements are enclosed by braces. Whereas, in the set builder notation, we have set C is equal to the set of elements of X such that X is a counting number from 1 to 10. Give the roster or listing form of the following sets. 1. Let n denote the set of first 5 natural numbers. So we have set n is equal to the elements 1, 2, 3, 4, and 5, and close with a pair of braces. Next, let's have number 2. The set of all vowels of the English alphabet. So we have set V is equal to the set of A, E, I, O, and U. The same, we have to enclose the elements with a pair of braces. Next, let's proceed to number 3. The set of all odd numbers less than 9. What would be the elements? It would be 1, 3, 5, and 7. Again, enclose the elements with a pair of braces. And the last one, we have the set of all letters in the word mathematics. We have set Z is equal to the set of the elements M, A, T, H, E, I, C, S. And all the elements are enclosed with a pair of braces. As you can see, the letters are written once only. Okay. Now let us transform the given set in set builder notation. So the given set is, let P is the set of counting numbers greater than 12. So we have P is equal to the set of X such that X is a counting number greater than 12. So as you can see, you can choose whether you have to use the colon or the bar. Now let us transform the given set in set builder notation. Let A denote the set of even numbers between 6 and 4. So we have two ways in writing a given set in set builder notation. So we have set A is equal to the set of all X such that X is an even number and X is greater than 6 but less than 12. Let's have another example. So we have set X. We have the elements 4, 5, 6, and 7. So we can write this in the form or in the set builder notation. So set X is the set of all X such that X is a natural number and X is greater than 3 but less than 8. Now let us operationally define the elements of a set. Now let us have this example. So let A be the set of the first 5 multiples of 4. So letter A or set A is equal to the set of 4, 8, 12, 16, and 20. So in here, 4 is an element of set A, 16 is an element of set A, 24 is not an element of set A, 3 is not an element of set A. In symbols, we have the following. So take note of the symbols for element and not an element. Now will you try to answer the following questions? So let's see B the set of consonants in the English alphabet. So we have the elements from B to Z. So let us answer the following questions. Is G an element of set C? Is M an element of set C? Is O not an element of set C? Are the elements of the set of vowels complete the set of consonants of the English alphabet? are you now ready to check if you got 4 points? Let us have number 1. Is G an element of set C? The answer is yes. Is M an element of set C? The answer is also yes. Is O not an element of set C? The answer is yes, because O is not included on the given set. If you are to combine the set of vowels and set of consonants, it would be the set of the letters of the English alphabet. The answer is also yes, because the set of vowels of the English alphabet completes the set of the consonants of the English alphabet. So if you got 4 points, well and good. If it's not, then you can go over with the examples. Next, I will give you 2 minutes to compare the 2 columns and try to identify the elements of the given sets. Okay, so you might observe that in the first column, that it is not possible to enumerate the elements of the given sets. Whereas, in the second column, we can. At least, the first and the last element can be identified. Yes, the sets in the first column are what we call infinite sets, and in the second column are what we call finite sets. Now, let us differentiate the 2 kinds of sets. So, finite set is a set that has a finite number of elements. Informally, a finite set is a set which one could count the elements and finish counting. How about infinite sets? If a set is not finite, it is called an infinite set because the number of elements in that set is not. Are there how many elements in each of the given sets? Okay, now let us analyze the entry in each row. So I'll give you another 2 minutes to do this activity. How did we arrive at the numbers written in the third column? So on the first column, as you can see, we have the given sets. So we have here the set of the colors of rainbow. So under elements, so as you can see, we enumerated the elements of the colors of the rainbow. And then how many elements we have? We have red, orange, yellow, green, blue, indigo, and violet. So we have 1, 2, 3, 4, 5, 6, 7. So we have 7 elements. So this can be represented as, or the cardinality of the set can be represented as N of R, which is equal to 7. Next, we have set D. So set D is the set of all x such that x is an odd number and x is greater than 0 but less than 10. So on the second column, the elements are enumerated, and these are 1, 3, 5, 7, and 9. So all odd numbers between 0 and 10. So what would be the cardinality of the given set? So N of D is equal to 5, or the cardinality of set D is 5. The last one, or the second to the last, we have the set of days of the week. So we have Monday up to Sunday. And it is a fact that in a week we have 7 days. So N of W is equal to 7. And the last one, we have the set of the letters in the word committee. So on the column, under elements, we have set S is equal to the set of COMITE. As you can see, the letters of the word committee are written in the second column. So we have COMITE, and the letter, or the letters are written once only. So we have here how many letters? We have 6. So N of S is equal to 6. Our discussion about set will be clearer to you with the use of Venn diagram. Venn diagrams were conceived around 1880 by John Venn. It is consist of multiple overlapping closed curves, usually circles, each representing a set. For now, let us use Venn diagrams to represent the following sets. First is our universal set. Now let us consider the set of the months of the year. The elements are January, February, March up to December. In here, the elements of our universal set are inside the rectangle. Usually, rectangles are used to represent universal sets. Now in the figure, we have circle C, which contains the elements of our set C. Next, we have circle W, also contains the elements March and April. Next, we have the elements April, June, September, and November are contained in circle T. Since sets C, T, and W are taken from our universal set, let us try to fit in all these sets in our universal set. All elements of C are also elements of B. April and June are elements found in our universal set E. As you can see in our illustration, all our smaller sets are contained in our universal set. Therefore, sets C, W, and T are all proper subsets of our universal set U, because all elements in these sets are elements of our universal set. Please do not forget the symbol for proper subset. Generally, A is a proper subset of B if and only if every element of A is in B and A is not equal to B. So we have A is a proper subset of B. Okay, now let us consider this example. So if we have set A, we have the elements 1, 2, and 3. Then we have the set containing an element 1. We have a set containing elements 1 and 2. A set containing the elements 1, 2, and 3. And the last one is a null set. All of these sets are proper subsets of the given set A. Let us proceed to our next situation. If set A is the set of all x, such that x is a vowel of the English alphabet, then the elements are A, E, I, O, and U. Here comes set B, written in roster method, and its elements are the same with our set A, which has the elements A, E, I, O, and U. Hence, set A is equal to set B. Therefore, set A is a proper subset of set B. Generally, A is a subset of B if and only if every element of A is in B and A is equal to B. So we have A is a subset of B. Now let us have this activity. Give the correct symbol for each problem. So we have the symbols for subset, proper subset, element, not an element. So given that set A is equal to the set of the elements M, A, T, and H, we have B for L-O-V-E, we have C, H, A, T, and D we have E, V, O, and L. Now let us answer the following. Number 1, we have the set of H, A, T. Then you have to fill in the correct symbol. We have the choices for proper subset, subset, element, and not an element. So you do the same for numbers 2 to 5. Learners, keep in mind the following key terms. Everybody, let us read. A set is a well-defined group of objects called elements or members that share common characteristics. Universal set is a set which contains all objects under discussion. If an element of set A are contained in set B and A is not equal to B, then A is a proper subset of B. In symbols, we have A is a proper subset of B. And if all elements of set A are contained in set B and A is not equal to B, then A is a subset of B. And in symbols, we have A is a subset of B. The number of elements in a given set is the cardinality of the set. Now we have here the 3 methods in writing set. The description or statement form, the roster or listing or tabular method, and we have the set builder notation. Hello! I hope you're still there. Thank you everyone. So much excited for our next episode. This is Teacher Jane signing off.